Hi everybody, today we're going to try another combination circuit. This one will be a little bit more challenging, but we'll talk you through it. So let's get started. On the left hand side of the screen you'll see the series circuit rules, the parallel circuit rules, Ohm's law, and Watt's law. And remember that my little T's inside this circuit represent Ohm's law, so the top number will be the volts, the left-hand side will be the amps, and the right-hand side will be the ohms for each of these T's. What I've done is shown you some drawings on the right-hand side that show you how to reduce this circuit down to just the equivalent of one resistor so that you can find out what the R total is for this circuit. Notice that this circuit has a resistor R1 in series with everything up front, then a branch that runs down, R2, then another resistor that's in series with R4 and R5. So to get started, we have to start reducing from the opposite end from the source. So the source is over there, so I'm going to look at this area first. And if you notice that what I did was I took R4 and 5, which are in parallel, and I reduced them down. So to do that, I'd have to go over here and look at my parallel circuit rules, and to reduce R4 and 5, I'd go 10 to the negative 1 plus 10 to the negative 1 and inverse that, so to the negative 1 one more time. So that value over here would actually be 5 ohms for R4, 5. Then if you notice, R3 is in series. So in this picture here, R3 is now in series with the equivalent R4, 5. So we have to use the series circuit rules, which means I just add R3 and R4, 5. And that'll give me R3, 4, 5. And that actually worked out because R3 was 10 ohms and R4, 5 was 5 ohms. We end up with 15 ohms here. Just add those two values together. And the next thing that we can see is R2 and the equivalent for R3, 4, 5 are now clearly in parallel, so we'll use the parallel circuit rules. R3, 4, 5 is 15 ohms, and R2 over here is 15 ohms. 15 to the negative 1 plus 15 to the negative 1 in brackets, and then inverse that, you will end up with 7.5. So all of this ends up being 7.5 ohms. When you look at this circuit, R1 is now clearly in series with the equivalent resistor for all of these guys, 2, 3, 4, 5, and I use series circuit rules to add them together, and I'll get 10 ohms as my total resistance. Then I could take that 10 ohms over here to my supply T, shows all my totals, so there was 12 amps total, 10 ohms total. That will give me 10 times 12 is 120 volts, and I know that's my source. Coming out of the negative will be my total current, and that is 12 amps in this case. So 12 amps has to run through R1. Now I have two numbers at R1, and we multiply 12 amps by 2.5 ohms, and we end up with 30 volts at R1. The next thing we can do is check around any closed loop. So all of the voltages around that loop have to equal our source. We had 120 volts there. We have 30 volts at R1 that we just calculated. That means, since there's only one more resistor in that loop, that R2 has to be the difference between 120 volts and 30 volts. So we know that R2 is 90 volts. If we take that 90 volts and put it over here in place of R2, we know that R2 is in parallel with 3, 4, and 5. So 90 volts will also end up being the same for 3, 4, 5. We can use a new T. This T represents the totals for R3, 4, and 5, and we found that there was 15 ohms as a total equivalent for 3, 4, 5, and I know that that's in parallel with R2, and R2 is 90 volts, so I can tell that all of that 90 volts is going to be shared by the 15 ohms. And so from that, I know that my current is going to be 6 amps. The next thing we can do is say, if I have 6 amps flowing out to R345, that means I must have 6 amps flowing through R3. So I'm going to have 6 amps right there to use. And now I have two numbers. 6 amps times 10 will give me 60 volts. I can check with another closed loop. I can use the loop inside here. I started with 90 volts across that resistor, so that means R3 and R4 also have to equal 90 volts. If we have 60 volts already at R3, it means that only 30 volts are left, and that has to be our voltage for R4. There are no resistors on the top or the bottom of this, so R4 is in parallel with R5, which means R5 also has 30 volts. We can double check all of this. We can say one more closed loop would be the outermost loop there and all the way back. And in this case, I start with 120 volts was my source, and that has to equal all of the voltage drops around here. So I have 30 volts at R1, and keep going, I have 60 volts at R3, and then I had 30 volts at R5, and all of that added up does give me my 120. So I know that I've done those voltages correctly. Thanks.